finally, let's solve a problem where there are specified uh, displacements or settlements of the supports. So this is example 5.9. This is our last example. For the continuous beam shown, some supports undergo settlements as indicated. Determine the nodal displacements and reaction forces. E is 200 gigapascals, I is 200 times 10 to the 6. So E 200,000 megapascals times I 200 times 10 to the 6. That would be in Newton mm squared. You divide that by 1,000 squared. The result is 40,000 kilonewton meter squared. So there are 5 degrees of freedom. This is possible in the test or a quiz. So, but because we have a technique that we can reduce this to 3 by 3 by considering only A, B, C, D, and we just incorporate the moment effect of this load at E, which produces counterclockwise moment of 60 times D, which is 180. So these are the effect of the fixed end moments due to the loads. And of course, we have 180 there. So consider a strip. 50 is the height, thickness dx, then the distance from the left is x. So that the distance of the centroid of strip from the left is 1 plus x. So fixed end moment in the second portion also, 50 dx. Let's call this distance here as x. So x is flexible. You can put it anywhere as long as the distance is correct. Then this is, if I denote this x from the zero load, then the height is 60 divided by 610. So the height of the strip is 10x. So we are now ready to compute fixed moment AB, which is equal to integral 0 to 5 of 50 dx times x plus 1, 5 minus x quantity squared over 6 squared. This is expected counterclockwise. Then the sideway moment, which is in this case, the formula is negative 6EI delta over L squared. And delta in this case, because the chord AB is rotating clockwise, so delta, which is equal to 15 mm or 0.015 meter, is considered negative. Considered positive because this is clockwise. But there is a negative sign preceded, so fixed end moment AB due to the load is 5525 over 24. Fixed end moment BA, integral 0 to 5 of 50 dx, quantity x plus 1 square, quantity 5 minus x divided by 6 square, then minus 100. By the way, the fixed end moment due to sideway is negative 100. And negative 100 means that it is, because we use slope deflection, it is counterclockwise. So we expect clockwise moment here due to the load, and the fixed moment due to side sway is counterclockwise. So there's no problem with this because we are going to add 100. But for the second part, because this is clockwise and the moment is interpreted due to side sway is interpreted as counterclockwise, so we have to subtract negative 100. So fixed moment BA is 3425 over 72. So force A times 6 plus this moment 3425 over 72 equals moment sa A is 5525 over 24 plus moment of the load 50 times 5 times 2.5. So FA is 134.606 kilonewton meter. FBL is summation versus Y. FB left plus 134.606 equals 50 times 5. So we get FBL equals 115.394 kilonewtons. Fixed moment BC is B to C. The chord is rotating counterclockwise this time. So fixed moment due to side sway BC. So this time let's separate the result. The result here is positive, so it means it is clockwise. So fixed moment BC is 1 1,200 over 49 Newton clockwise in BC, but we expect counterclockwise moment in BC due to the load. Remember, this is clockwise. For the load, fixed moment BC due to the load, the L there is for load, 0 to 4 of 50 EX times quantity 4 minus X. The distance here is 4 minus X. Its distance from the right is X plus 3. Quantity square over 7 square. So it is equal to ECL is 23600 over 147 kilonewton meter, and that is counterclockwise. Therefore, the net moment at BC is 23600 over 147 minus 1200 over 49 because that's clockwise. So, and we expect counterclockwise moment in BC. So 136.0544 kilonewton meter counterclockwise, which is this direction. Then for CB, so we use the same integral, and because this is clockwise, then we add 1200 over 49 because they have the same sense for sideway moment. So 50 dx, quantity 4 minus x squared over 7 squared times x plus 3, just interchange the squared term, over 7 squared, then plus 1200 over 49. Fixed end moment CB therefore is now 111.5646 kilonewton meter clockwise, which is expected. Then moment CD due to side sway. So negative 6 times 40,000. By the way, EI is 40,000 as I mentioned. Then the rotation of the chord C to D is clockwise again. And the net rotation is 30 mm. So 40 minus 10 is 30 mm. So 0.03 positive over 8 squared. The result is negative. So this means this is counterclockwise. So fixed end moment CD due to side sway is 112.5 kilonewton meter counterclockwise. We expect counterclockwise also as positive. And due to side sway, due to load is integral of 10x times quantity 6 minus x times x plus 2 quantity square over 8 square, 0 to 6. So it is expected counterclockwise. And because this is counterclockwise, so the net fixed moment in CD is, we add the 2. So that would be 263.25 kilonewton meter. So that's counterclockwise. Then fixed moment DC is equal to same integral. Then we have, because we expect clockwise moment here, and this fixed moment due to sideway or settlement is counterclockwise, so we subtract it because this is clockwise expected. So the result is negative 38. So meaning to say it is not clockwise, it is counterclockwise. So we just put negative 38.25 there, and let's assume that this is true, that the value is negative 38.25. So therefore, fixed moment DC is 38.25 counterclockwise. Take note of that. So summation moment about D is about considering BC. C is 0, so FBR times 7 plus fixed moment CD. Fixed moment CD is equal to 111.5646. Then it is equal to fixed moment BC, which is 136.0544 plus the moment of the load, this is 50 times 4 times 5. 5 is the moment I'm about to see. So FDR is 146.3557 kilonewton. Summation forces Y in BC equals 0. So FC left plus 146.355 equals 50 times 4. So FC left equals 53.6443 kilonewtons. Then for CD, summation moment of D0, FCR times 8 plus negative 38.25. Remember, this is counterclockwise, so I just take the sign. Equals moment CD, which is equal to 263.25 plus moment of the load, 1/2 of 6 times 60. 4 plus 2 is 6 moment time. So FCR is 172.6875 kilonewtons. So that's it. Let's proceed to FD left plus FCR equals moment equals area of the loading 1/2 of 6 times 60. So FD left is 7.3125. Then for the nodal forces, node 1, 0 because that's fixed. So node 2, we have fixed and moment BA 3425 over 72 minus fixed and moment BC, which is 136.055. And the result is negative, so that's why it's clockwise here, 88.485. At node 3, we have fixed in moment CD, which is 111.5646 minus fixed in moment CD, 263.25, and I think it's negative, so it is clockwise also, 151.6854. Then at node 4, this is negative 38.25, and this is counterclockwise, so minus 180, so negative, 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 so negative, so it should be clockwise, negative 218.25. So these are the nodal forces. Important nodes are 2, 4, 6. Oh, sorry, 4, 6, 8, which corresponds to theta B, theta C, and theta D. So let's have the stiffness of member KED, which is 12 divided by 6 cube, and we already encountered that, 1 over 18. So we copy the stiffness for a span of 6. Then the second one is 12 over 7 cube. We also experienced that. So 12 divided by 343, we already have that values. KCD, the span is 8. We already have that. So I copy the stiffnesses and the nodal loads so that this will serve as our guide in computing the displacements. KCD is 12 divided by 5678, 5678. We divide by the span cube. So 3 over 128, and we already experienced this. So you just cut and paste. And these are the global forces. Again, we need 2, 4, 6, and 8. So 4, 6, and 8. So these are the nodal loads or global forces. Everything was clockwise, so they are all negatives here. Then for 4, we have 2/3 and 4 over 7. 2/3 plus 4 over 7 is 26 over 21. Then we have 4, 6. We only have 1. 4, 6. This one, 2 over 7, 2 over 7. 4, 8, there's none, so 0. So 2 over 7 is also 6, 4. Then 8, 4 is also 0. Same like that. This is 6, 6. 6, 6 is 4 over 7 plus 1/2. 4 over 7 plus 1/2 is 15 over 14. This is 6, 8, and we only have 1/4. So 8, 6 is also 1/4. And finally, 8, 8 is 1/2. That's 1/2. U4, U6, U8, therefore, is the inverse of this 3 by 3 matrix times this force matrix here. It can be easily computed using your calculator. So negative 88.485 over EI. Sorry, these are the forces. So inverse of this 3 by 3 times this force matrix. So negative 65.6658 over EI. Negative 25.1459 over EI. Negative 423.9271 over EI. Then in terms of radians, we divide everything by 40,000. So U4, U6, U8 equals divide by 40,000. because EI is given. So in radians, these are the answers. So this corresponds to theta B, theta C, and theta D. So theta B, theta C, and theta D. Now for the member forces. By the way, let's now include DE here. So this is the portion DE. So remember that there's no fixed in force here, because if you sum up, remember this is fixed ended. And if you take moment about that end, then there will be no moment. There's also no moment because the load is acting over the fixed end. So it cannot produce moment in the span. So FBR is 0, moment BR is 0, fixed end moment DE is 0, then fixed end moment ED is 0, but summation versus Y equals 0, we have a reaction here at E, which is FEL rather, and this is FDR. Then the result would be this FEL equals 60 kilonewton. So FDR equals 0, while FEL is equal to 60, is equal to 20 kilonewton. No, 60 kilonewton. And the nodal load is also opposite to that. So negative 60 global forces. So this is the stiffness of member DE. I already incorporate it. Then 7, 8, 9, 10. The only portion that has displacement would be 0 for U7, then U8, unknowns U9 and U10. So let's expand rows 9 and 10 here, although any other two rows may do so. So negative 60 of 0 then equals this matrix here times the displacement matrix which is given, plus this 2 by 2 matrix, 4, 9, negative 2/3, 2/3, 4/3 times the unknown displacements U9 and U10. So negative 342.6181, the simplification, negative 60 minus 4 over 9 times 0, negative 60, then minus negative 2/3 times negative 423.9271, that's the value. 0 minus quantity 2/3 times 0, so 0 minus 2/3 times negative 423.9271, so it becomes positive 281.6181 equals this matrix here times U9, U10. Solving for U9, U10, using your calculator, then you'll get negative 1811.781 over EI and negative 693.927 over EI. Then in mm and in radians, we divide by 40. That's the technique to make it mm, 40,000 for theta for U10. So U9, U10 would be negative 45.295 mm and negative 0.0173482 radians. That corresponds to, this corresponds to delta E and theta E. Then for the member force of AB, only U4 is present. So cover or shade columns 1, 2, 3 again. Then fixed and forces here. So 16 times negative 65.6658 plus 134.606, 123.662. And kindly verify these values. You just multiply and add the fixed and force. And that's the final fixed and force. For BC, this is the stiffness, displacements at 4 and 6. So we shade 3 and columns 3 and 5. So 6 over 49 times negative 65.6658 plus 6 over 49 times negative 25.1459 plus fixed in force. We'll get these forces and so on. So we already experienced this calculation. You just verify these answers. Then for member CB, will be the results. stiffness, and we have U6 and U8 only. So shade 5 and 7, and distribute plus the fixed forces, corresponding fixed forces, you will get this result. Then DE, DE for DE, stiffness, then you have U8, U9, U10, then distribute. There's the fixed forces, 0, 0, and we have 60 for this end here, FEL, upward, then everything is 0. Then sample calculation for this row 3 here, negative 2/3 times negative 423.9271 plus 4 over 9 times negative 1811.781 plus quantity negative 2/3 times negative 693.927 plus 60. The result should be 0 because the shear at the end at EL must be 0, or D left must be 0. And finally, moment ED is also 0. So that's it.